He said one day you'll leave this world behind, so live a life you will remember. My father told me when I was just a child, these are the nights that never die. My father told me.
So hi everyone! Today we're gonna be dealing with electrochemistry. We're gonna be talking about electrolysis and electroplating. A problem will be given to us and we're gonna make an electroplating design, electroplating setup to solve that certain problem. But first, let's talk about electrolysis. What is electrolysis? Electrolysis is when there is an electrical flow through a liquid in order to make chemical changes. We're gonna be talking about key terms such as oxidation, reduction, anode, cathode, battery, and electrolyte. So those are the key terms we're gonna be dealing. So we're gonna be making an electroplating design in order to solve a problem. So I'm gonna be talking about that problem later on, and then I'm gonna show you my own electroplating setup. So first, we have to remember, we have to stick in our minds what is an anode and what is a cathode. So in this electroplating setup and in this vlog, we have to remember that anode is when there is a pool of electrons, and then this is where oxidation occurs. However, in cathode, there is a push of electrons, and this is when reduction occurs. Alright? We also have to stick in mind that electroplating is a type of electrolysis. As what I have researched in the internet. So, hi everyone. So this is the problem given to me. I'm gonna read it. So, my grandmother gave me silver-plated kitchenwares. These are old such that some parts of the plating are already worn off. Design an electroplating setup to restore these heirloom pieces. I'm gonna extract keywords from this problem. So, silver-plated kitchenwares, and then electroplating and heirloom pieces. Now, I've been searching electroplating silver for almost 3 days now, and I wasn't able to find anything. But then I went back to the problem and then extract silver-plated kitchenwares, and I realized that there must be a difference between silver-plated and, of course, real silver kitchenwares. But then I searched through the web the difference between silver, sterling silver, silver-plated, and vermeil. So here I was able to know the difference of these key terms. So as you can see, this is a sterling silver, and stated here is the difference between silver and sterling, but we're gonna focus on the silver-plated. It is mentioned that silver-plated jewelry has an extremely thin layer of silver, measured in microns, converting a base metal, commonly copper, brass. As mentioned, it has a base metal which is copper, so it is not completely silver. So here, as you can see, that the picture showed that the silver-plated has a base metal such as copper. So I searched through the internet again if what are the common base metal of silver-plated flatwares. So it is mentioned here that it is not always brass underneath. It is commonly copper-based. That's the base metal of the kitchenware in my electroplating design. Copper is used as a base metal. So I guess that's it. Now let's go to the next term, which is electroplating. Now as you can see, electroplating is the process of coating a metal with a thin layer of another metal by electrolysis to improve the metal's corrosion resistance. So the problem said that the kitchenwares are already old. So these are silver-plated. So some parts of these kitchenwares are already worn off. So we're gonna design an electroplating in order to restore these heirloom pieces through electroplating because it is the process of coating a metal. So we're gonna coat kitchenwares with base metal such as copper. So as what I have mentioned, electroplating is the process of coating a metal with a thin layer. So we're gonna coat that silver-plated kitchenwares with silver in order to restore these heirloom pieces. So what does heirloom mean? Heirloom means a valuable object that has belonged to a family for several generations. So we're gonna restore those heirloom pieces. So now, let's go to my electroplating design. Since we are done extracting the keywords from the problem, let's go to my electroplating setup, which I designed using an Illustrator, which is the Designer Pro. As you can see, this is my electroplating setup. It has a piece of silver, it has a base plate with copper and thin layer of silver, and it has an electrolyte, which is the silver nitrate. As you can see, it has a battery. Now, this piece of silver is the anode, as you can see. And then, this other one, this base plate with copper, is the cathode. So that will serve as our heirloom pieces. So that will serve as the kitchenware. It has also a battery. So, because as what I have mentioned in the first part of the vlog, that electrolysis is wherein we use electricity in order to make chemical changes. That's why we are going to use a battery in order to make chemical changes between these three. So, as you can see, we have an electrolyte as the silver nitrate. And then, there is an arrow pointing that way that signifies that electrons are moving towards the battery. So, while the other one signifies that the movement of electrons is through this way. So hi everyone, since I'm already done with the introduction of my electroplating design, right now we're gonna be knowing how it works, and then we're gonna be zooming in into an atomic level in order to know how it works. So as you can see, as what I have discussed earlier, this is my electroplating design, and then it has a battery, electrolyte, piece of silver, and of course our flatwares. You can see here that there is an arrow pointing towards the battery, which signifies that electrons are moving that way, and then there's also an arrow pointing this way, which means that electrons are moving this way. So now, our main goal is to have atomic silver being transferred into the copper in order to perform the electroplating, in order to restore these heirloom pieces. Now, first, let's focus on which side of the battery is this connected or is that connected. As you can see here, that this piece of silver is connected to the positive side of the battery, and then this copper with thin layer of silver is connected to the negative side of battery. Now, that's actually the main goal of this electroplating, in order to change the charges of these pieces of silver, some atoms of it, and in order to transfer some pieces of silver towards the base plate with copper and thin layer of silver. Now, let's zoom in into an atomic level in order to know it. As As you can see here, we have pieces of silver, which is Ag, and then we have copper flatware, which is Cu, and here is the battery. Now, I've already discussed earlier which electrolyte we used. Now, it is quite important to have this electrolyte. For example, we just have a piece of silver and a piece of copper flatware, and then just pure water. That pure water cannot is not a good conductor of electricity, so electrons cannot flow through it. That's why we use an electrolyte, because when we mixed electrolyte with water, that's the time that the water will have impurities, and then it can be a good conductor of electricity. That's also the time that electricity can flow. So that's the main purpose of our electrolyte. Now let's focus here on the piece of silver and the copper flatware. As you can see, I have here written, this is very important, that neutral atoms make up solid metals. However, metal ions can dissolve in liquid. As you can see, this piece of silver has neutral atoms, which is the Ag. So, what I have said earlier, that electrons are pulled by the battery, because this is the positive side of the battery. So, since, for example, this Ag atom, for example, that one electron will be pulled by the battery. Electrons are pulled by the battery because this is the positive side of the battery, and that is where the piece of silver is connected. For example, this Ag. So, one electron from this Ag is pulled by the battery. So, since one electron of this Ag, let's zoom it in. For example, this Ag. So, this is solid because it's neutral. So, for example, this Ag. One electron from this Ag is pulled by the battery. So what happens to it is that it becomes positively charged. So it will become Ag plus. So it will become an ion. So since it already became an ion, it will no longer be part of this solid piece of silver because this is neutral. Since we already changed the charge of this Ag, since we pulled one electron out from it, it will become positively charged. So, let's have another Ag. For example, this Ag is neutral, and then we're gonna be pulling electrons out from it. It is pulled by the battery. So, this Ag will become positive, and then it will no longer be part of the solid piece of silver. So, it's already in the electrolyte, it's already in the solution. Now, let's remember our main goal. Our goal is to have atoms of this silver to be part of this copper flatware in order to restore it. So, since this is already metal ion, it is now part of the solution, and then it is no longer liquid. But the question is how? How are we gonna put these atoms on the surface of the copper? So, then again, we're gonna be using the battery. That's the function of the battery. We're already done with changing the charge of this Ag atom. Now, it is now part of the solution. It is no longer liquid because it became an ion. Now, we have to find a way in order to stick these silver atoms into the surface of this copper. That is when the battery will do its work. So as you can see, the negative side of the battery is actually connected to the copper flatware. So if that's the case, then electrons will be pushed towards the copper. So in order to put these Ag atoms into the surface of copper, we have to go back into this statement again. It said that neutral atoms make up solid metal. In order to make it a solid metal, we have to change its charge again. We have to turn it into a neutral atom. So how is that gonna be possible? That's possible because of the battery and because of the electrolyte. Since the negative side of the battery is connected to here, electrons will be pushed towards here. So since electrons is pushed towards here, Ag will be attracted to this copper flatware since opposite charges attract. So if Ag is gonna be attracted here, let's say that Ag, so I apologize for the chickens if they are too noisy. So let's go back to the explanation. Now here, since electrons is pushed towards the copper, it is pushed by the battery, and then that's actually the time wherein the Ag is attracted towards the copper. And if that's the case, if electrons will be put here, that's actually the time wherein Ag will go back to being a neutral atom. And then neutral atoms make up solid metal. That's also what will happen to other Ag, to other silver atoms. So let's do that again. Again, for example, this Ag, it is already in the solution. It is positively charged, and because of the electrons, if electrons are moved here, so that electron, Ag will be attracted towards the copper. Let me draw that arrow here. So Ag will be here, but it's still positive. But when electrons will be here, that's actually the time wherein Ag will go back to being neutral. So that's just how it works. So again, recap, what we did is that we let the battery change the charges of the atoms in order to transfer silver atoms towards the copper flatware. So again, recap, what we did is that we let the battery do its work, and then because of the electrolyte, since electrolyte is a good conductor of electricity, so if electrolyte is mixed with water, water will have impurities, and that's also the time wherein that liquid will actually be a good conductor of electricity. So that this allows the battery to do its work. The electrolyte permits the battery to do its work. The battery will change the charges of Ag. So if the battery will change the charge of Ag, it is because it pulled the electrons away from Ag, making the neutral atom positive. So since it is positive, we have a rule here that metal ions can dissolve in liquid, so it is positive. So now we have to find another way in order to stick the Ag to the copper, in order to put the silver atoms to the surface of the copper flatware. So here, electrons will move towards the copper, and then it attracts Ag, and then when Ag is attracted, once that happens, the Ag will no longer be a metal ion. It will no longer have that positive charge, because of course, if it will have an electron, if it will gain another electron, it will no longer be positive. It will be back to its neutral charge. It will become a neutral atom, so it will now become a solid. So that's just how it works. So if you have any questions or any corrections, just feel free to comment, to share, to subscribe, and then because I'm also just learning this electroplating and this electrolysis. So if there's any question, if there's any comments, if I made any mistake, I'm open to it. And then just comment this vlog, and then stay safe because of coronavirus. Wash your hands, sanitize wherever you are right now, pray hard. So again, this is Beatrice Benoligrao explaining electroplating. I hope you learned something from me, and I apologize of the chickens because they are too noisy, but I hope I made my point clear. So that's again my electroplating design. So see you on my next vlog. keep safe and pray hard. Bye. So I wasn't able to discuss the reduction, oxidation, because that's under chemistry, but I hope you learned something. That's just the surface of the idea of electroplating. I haven't discussed it deeply, but I hope I made my point clear, and the chickens are not mine. It's from my neighbor.
He said one day you'll leave this world behind, so live a life